Was there a Martian civilization? We have compelling evidence that rivers and lakes existed on Mars a while ago. Scientists believe that some environments on ancient Mars may once have provided conditions suitable for life as we know it. Could a technologically advanced civilization have existed there? And would there be anything left for us to find? Hello, Dr. Alejo here. Spoilers ahead for Season 4 of Star Trek: Strange New Worlds, episode Vallis Marineris. In the episode, the crew of the Starship Enterprise traveled back in time, to be precise, to the time when dinosaurs still ruled the Earth. As part of that plot, they encounter a Mars inhabited by a humanoid Martian civilization capable of spaceflight. In other words, these Martians were already technologically advanced 65 million years before humans even existed. However, there's a massive problem with this timeline. By 65 million years ago, Mars had already been a cold, dry planet with a thin atmosphere for billions of years. If a civilization existed there at that time, it would probably need to have evolved much earlier and then survived underground, inside artificial habitats or through some form of planetary engineering. But let's leave that minor detail aside. Would it be possible that a race of intelligent Martians existed on the planet when the conditions for life were favorable? Let's have some fun discussing this possibility. We have always been obsessed with the possibility of intelligent life on Mars. In 1877, the Italian astronomer Giovanni Schiaparelli mapped Mars and reported a network of dark, straight surface lines. He called them canali, which is Italian for channels. That is something that is natural, like a channel left by a river, for instance. However, the word was mistranslated into English as canal, implying that they were artificial waterways built by intelligent life. Percival Lowell took the mistranslation literally and believed he could see dozens of those canals on the surface of Mars. He was absolutely certain that an advanced network of canals had been built by Martian engineers to transport water from the poles to the rest of the planet. The truth is that those canals, or channels, don't exist. They were probably an optical illusion at first, and then a very subjective belief that Percival Lowell and his followers didn't want to let go of. When the Viking spacecraft landed on Mars in 1976, they observed a frozen desert, a planet whose atmosphere is less than 1% as dense as Earth's, where liquid water cannot remain stable across most of its surface, and which is constantly exposed to radiation from space. In other words, a world whose surface appeared extremely hostile to life as we know it. But billions of years ago, Mars was a very different place. Rivers crossed its surface, lakes filled its craters, rain or melting snow may have fallen from its sky. The planet possessed a thicker atmosphere and perhaps environments in which life could survive. In 2008, NASA's Phoenix lander excavated the northern polar soil and directly confirmed water ice only centimeters beneath the surface. It also found mildly alkaline soil containing salts and possible nutrients, calcium carbonate, which can indicate past interactions with liquid water, and perchlorates. These compounds can be toxic to some organisms, but certain microbes can use them as an energy source. The antifreeze properties of perchlorates could allow salty water to remain liquid at lower temperatures, meaning that salty liquid water might temporarily form under freezing Martian conditions. However, we don't know yet if water forms regularly or if it could support life. Between 2013 and 2015, NASA's Curiosity rover found evidence that the Gale crater appears to have held a series of lakes approximately 3.8 to 3.3 billion years ago. Sediments accumulated in these lakes and eventually formed the lower layers of Mount Sharp. At Yellowknife Bay, Curiosity also detected clay minerals and the chemical elements carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus. These are some of the essential ingredients required by life as we know it. The environment was not extremely acidic or excessively salty, and chemical reactions in the rocks could have provided energy for microorganisms. More recently, Perseverance has explored Jezero crater, where an ancient river transported sediment into a lake and created a delta. In 2024, Perseverance examined a rock called Cheyava Falls, containing organic carbon and unusual mineral-rich reactions fronts known as leopard spots. Some of its chemical characteristics could be consistent with ancient microbial activity. In 2025, the peer-reviewed analysis identified the Sapphire Canyon sample collected from this rock as containing potential biosignatures. However, these minerals and organic compounds can also form through non-biological processes. The discovery, therefore, doesn't prove that life existed on Mars, but it may represent Perseverance's most compelling candidate so far for chemical processes potentially compatible with ancient microbial activity. But even if we find evidence of possible microbial activity, this is not the same as evidence of complex organisms. And complex life is still separated from technological intelligence by an enormous evolutionary distance. So, the important question here is, did Mars have enough time to produce an advanced Martian civilization? Earth formed approximately 4.5 billion years ago. The evidence suggests that life appeared relatively early in our planet's history, but technological intelligence took billions of additional years to emerge. Complex animals only became widespread during the last 600 million years. Our own species apparently roughly 300,000 years ago. Industrial civilization has existed for only a few centuries, and 200 years ago we couldn't even fly. The first satellite was launched only 70 years ago in 1957. Mars, by comparison, appears to have lost much of its surface habitability relatively early. After Mars lost its global magnetic field, its atmosphere became more directly exposed to the solar wind. Over immense periods, solar radiation, atmospheric escape, and other physical and chemical processes removed much of the atmosphere, contributing to the planet becoming colder and drier. Surface water froze, evaporated, or escaped. There is evidence that rivers and lakes may have existed occasionally as recently as 2 or 3 billion years ago, but the planet's most favorable and extensive habitable environments probably occurred much earlier. If Martian life followed exactly the same evolutionary timetable as life on Earth, it may simply not have had enough time to produce an advanced technological civilization. Microbial life might have appeared, but the surface could have become hostile before multicellular organisms, and eventually intelligence, of course, had the opportunity to evolve. But we can't really be sure that if life indeed existed on Mars, it followed the same path as the one that life followed on Earth. Earth provides our only known example of biological evolution. We don't really know if the billions of years separating simple life from technological intelligence represent a universal requirement, or if this is only the particular history of our planet. Evolution doesn't follow a predetermined path. Under different environmental conditions, important evolutionary transitions might happen more quickly, more slowly, or never occur at all. The appearance of intelligence on ancient Mars, therefore, cannot be described as impossible, but based on the only biological history we know, it would require evolution to have progressed unusually fast, or habitable conditions to have persisted somewhere on Mars for much longer than the surface record currently suggests. Let's say, for the sake of argument, that a technological civilization did appear on ancient Mars. As the Martian surface deteriorated, life might not necessarily have disappeared immediately. Water could have remained underground, protected from ultraviolet radiation, cosmic rays, and extreme temperature changes. Subsurface environments heated by volcanic or geothermal activity might have remained habitable after rivers and lakes vanished from the surface. A sufficiently adaptable biosphere could therefore have retreated progressively underground. For microorganisms, this possibility is scientifically credible. On Earth, microbes survive kilometers below the surface, obtaining energy through chemical reactions between water and rock. For a technological species, however, the problem would be much greater. An intelligent civilization facing the slow collapse of its planet might attempt to construct underground settlements, exploit geothermal energy, manufacture artificial habitats, or migrate to regions where liquid water remained available. If it possessed spaceflight, it might even attempt to leave Mars entirely, which is, and apologies for another spoiler, part of the plot of the Star Trek episode. This creates several possible scenarios. The civilization might have become extinct as the planet lost its atmosphere. It may have gone to live underground. It could have migrated to Earth or somewhere else in the solar system, or it could have disappeared long before Mars became the world we see today. These are interesting possibilities, but they are just speculation unless we can find evidence of any of them. If an advanced civilization existed on Mars more than 3 billion years ago, we shouldn't expect to find a city standing there perfectly preserved in the desert. Even on Earth, cities don't survive geological time intact. Buildings collapse, metals corrode, sediments accumulate, rivers change direction. Impact events destroy the surface. Chemical reactions transform materials, and geological processes bury or erase entire landscapes. Scientists Gavin Schmidt and Adam Frank explored a similar question for Earth in what they called the Silurian hypothesis. Their study didn't claim that an earlier industrial civilization existed on Earth. Instead, it asked if we would be able to detect one in the geological record millions of years later. Their conclusion was that individual objects and cities would probably be poor long-term markers. A civilization might be more easily detected through its effects on the planet. Rapid changes in carbon isotopes, unusual deposits of metals, radioactive elements produced or concentrated by technology, and changes in sedimentation, erosion, or atmospheric chemistry. We have an episode in which we discuss this Silurian hypothesis in more detail, which I invite you to check out. On Mars, many surface objects exposed for billions of years would have been damaged by radiation, oxidation, wind-blown sand, temperature cycling, and meteorite impacts. But Mars also provides an important advantage. Unlike Earth, it doesn't possess an active global system of plate tectonics that continuously recycles the crust. Large areas of the Martian surface are extremely ancient. Impact craters, valleys, and sedimentary formations billions of years old remain visible today. This means that Mars might preserve parts of its ancient history better than Earth does. The most promising evidence could potentially be found underground, inside caves or lava tubes, beneath sedimentary deposits within ancient mines, or sealed inside geological layers that have remained protected from radiation and erosion. If we really want to be serious about finding this potential civilization, we shouldn't look for a structure that resembles faces, pyramids, or statues. We are really good at perceiving familiar shapes in random landscapes. This ecological effect is called pareidolia. The famous face on Mars, photographed in the Sidonian region by Viking 1 in 1976, appeared artificial because of the low image resolution and the angle of illumination, but higher resolution images revealed just an ordinary eroded hill. A genuine Martian technosignature would require evidence that cannot be easily explained by geology. An object containing manufactured geometric structures at microscopic scales, for instance, or an alloy or refined material with a composition unlikely to form naturally. We may also discover unusual concentrations of elements associated with mining, manufacturing, or energy production. Artificial nuclear activity could potentially produce distinctive isotopic ratios. However, unusual isotopic ratios wouldn't automatically prove technology, because some nuclear and geochemical processes can occur naturally. A civilization that changed the Martian environment on a planetary scale might also have left anomalies in ancient sedimentary layers. Large underground cavities with regular internal structures could be investigated using ground-penetrating radar or seismic instruments. Potential mining sites might reveal excavations or patterns of material removal inconsistent with volcanic, fluvial, or impact processes. We could also search Mars' moons, Phobos and Deimos. They may preserve objects placed in orbit, although their surfaces have also been exposed to impacts and space weathering for immense periods. An advanced civilization might have sent spacecraft to Earth, the Moon, asteroids, or the outer solar system. In some cases, an artifact stored in a stable environment away from weather and geological activity might survive longer than anything left on the Martian surface. Contrary to some stuff we see on the internet, the claims of Martian images showing pyramids, doorways, statues, or machines are not scientifically valid. There is nothing that indicates that an ancient Martian civilization ever existed. However, the absence of evidence is not evidence of absence, or in this case, the lack of evidence doesn't completely rule out the possibility that a Martian civilization once existed. The more extensive and technologically active the civilization, the more difficult it becomes to explain why we have detected no evidence so far. This means that if a civilization indeed existed, it would have been a civilization that was geographically limited, existed very briefly, left a relatively small technological footprint, or had most of its remains destroyed, located underground, or in regions we haven't explored. While many future scientific missions will continue searching for evidence of ancient microbial life, they could also search for unusual materials or structures. Artificial intelligence could examine high-resolution orbital images for geometric features, repeated patterns, and surface anomalies. Radar instruments could identify underground formations and lava tubes. Future rovers could analyze isotopic ratios, metals, and complex materials that current missions weren't specifically designed to classify as technology. Samples returned to Earth could be studied with way more precision than is possible with instruments carried by a rover. And of course, human explorers would dramatically expand our ability to investigate caves, cliffs, sedimentary layers, and unusual geological formations. So, was there an ancient civilization on Mars? We have no credible evidence that intelligent Martians ever built cities, machines, or spacecraft. But scientifically speaking, we cannot be 100% sure that this wasn't the case. Some environments on ancient Mars appears to have offered conditions potentially suitable for life. Some regions may have experienced potentially habitable conditions over hundreds of millions of years, and protected environments underground may have persisted for longer. But there is an enormous gap between a habitable lake and a technological civilization. As it happens in many cases in science, and especially in the SETI field, we don't know seems to be the right answer at the moment. But imagine the possibilities in what we could learn if Mars was indeed the home of an advanced civilization in the past. Imagine finding the ruins of a civilization that disappeared billions of years before the first human looked into the night sky. One speculative form of evidence scientists have proposed searching for is micro-technosignatures, or micro-artifacts. These are hypothetical tiny particles that could be present on some of the surfaces of planets and satellites in our solar system. We explored this possibility and how some scientists are suggesting searching for them on our moon in a previous video. As always, thank you for watching and for being part of this growing community. Please consider subscribing to the channel, giving this video a like, and also adding a comment. Do you think it is possible that an ancient civilization existed on Mars? That's it for now, and remember, the truth is out there.